Hi, everyone. My name is Joe Wright, and I'm a software maintenance engineer for Red Hat. Unfortunately, not with me today. Also, with some content, Tom Kreider, a technical or senior technical support engineer for Red Hat. You're all probably wondering what Red Hat actually has to do with gaming, or why Red Hat's even sent somebody here. For those local to the Raleigh area or the Triangle, you've probably seen the big building downtown with the big Red Hat logo on top. As far as who or what Red Hat is, you may wonder who we are. Well, it's a valid question, especially given that we're not exactly a household gaming or household name in gaming. Of course, that's whether PC or console. And you would right to be assuming that Red Hat does not make video games, because we don't, unless somebody decides they want to. We also have our own esports team. I'm a member of the 2021 spring season CEA Overwatch team. And we also have a number of teams for Overwatch, CSGO, Dota 2, Rocket League, and a few others also listed here. And the question is then why is Red Hat at a gaming convention, or seemingly randomly popping up at events like DreamHack or GDC or any other video game-centric event for that matter? To answer that question, again, no, we don't make video games, and we're not a gaming company in the sense of the term. Well, then what does Red Hat do, and why are we here? That's kind of a broad scope, because Red Hat makes broad-scale contributions to the open source community at large. Many of those tools are used in games development or in various resources, infrastructure, the internet itself even. And no, I'm not here to sell you on Red Hat's product portfolio. We're not here to give you some executive speak sales pitch on OpenShift, OpenStack, RHEL, any of that stuff. What I'm here to do is actually, aside from Red Hat, introduce the community to options that they may or may not know that are available to them within the gaming community. Of course, just a little bit more about Red Hat. Our products and services are used by everyone from video games industry, Hollywoods, bank, even the military. Like I said, the internet itself is powered by numerous open source technologies, many of which Red Hat provides within the Red Hat ecosystem. But of course, I'm here to talk to you about gaming. And I still haven't fully answered as to who or what Red Hat actually is. Well, first and foremost, we are open source. But what exactly does that mean? Open source is likely a term that some of you in school or in IT or other technical aspects may have actually heard of. If you haven't, well, there's plenty of legalese that I can speak off here. Nobody really wants to hear that. The term open source originally refers to open source software. And open source software is developed largely in a collaborative manner. And that's what that means, is that there's peer-to-peer involvement all over the world with developers everywhere from here to Hong Kong to the Middle East to Russia to Eastern and Western Europe, you name it. And that individual product, which would be the software that's being developed, could be a game. It could be an application like LibreOffice. It could be hardware drivers, literally anything. And probably, I've already said this probably, the single largest example of open source technology would be the internet. And the internet as a whole is kind of essential to gaming, especially nowadays. And really, it's become almost a requirement to function in modern society, at least in our part of the world. the internet is the single largest, far-reaching, and most powerful means of sharing and communication that humanity has ever come up with. You and I can talk to somebody in India, Australia, England, doesn't matter where we are. We can share literally anything, at least within the bounds of legal sharing, with anyone in real time. It's largely decentralized with notable exceptions that I can't really get into here, and is mostly a free forum. The internet was developed by telecom engineers who relied on open and collaborative research within their workspace. This laid the groundwork initially for something called ARPANET, which was the foundation of the internet. And people working on that project relied on open source principles to be able to develop that software. And by the birth of the internet in the 90s, these open standards within open source software were baked into the foundations of the internet itself. For content creators, for stuff that's available to you within the gaming ecosystem, and this is all just showing open source resources that you have that are in addition to gaming and are relevant to gaming and content creators anywhere. Most of you, if you stream, are familiar with OBS or Streamlabs OBS. For those of you who don't, it's a program for basically turning your computer into a broadcast or command and control center for your live streams, whether it be to Twitch, YouTube, Facebook, what have you. It's fairly simple to get started with and is broadly supported within the open source community. And it currently supports Windows and most Linux distributions. For those of you who do make YouTube videos, you've got Kdenlive, which is a nonlinear editing platform similar to DaVinci Resolve or Final Cut Pro, whatever you happen to be using. Except this is open source, this is community developed, and you don't have to pay a dime for it. It's basically, I mean, they say it themselves on their homepage. Free and easy to use for any purpose forever. So it literally is free. Another program for those who are doing content creation, Audacity. That's going to be your audio mastering solution as an alternative, something like Pro Tools. For those who are doing image manipulation, like photography and whatnot, you've got Darktable and GIMP, which is your sort of your equivalents to Lightroom and Photoshop. And for actual vector graphics creation, you've got Inkscape. Now, for the game developers that I'm pretty sure are listening here, you've got all kinds of utilities that are all open source, all available to you. Blender, some people have a love-hate relationship with it, but it is pretty much ubiquitous in the development, maker, VFX, and animation spaces. It's one of the most powerful 3D suites available, and it's available for basically everything that's Linux, Windows, and Mac. It's also a free and open source tool, and it's got a massive community of contributors the world over. GIMP, Inkscape, and Audacity I've already covered, but these are also commonly found tools that could be in your professional workflow. And we have something new that you may not have heard of. It's called Open 3D Engine. As a leader in open source solutions, Red Hat knows how instrumental open source communities can be in creating innovative solutions to the pressing needs and challenges of various industries. And we're honored to be a founding member of the Open 3D Foundation, an initiative that will empower developers to collaborate and thereby shape the future of 3D visual experiences. Now, moving on to why you're really here. What if I told you that there was a real alternative? What if I told you that you could game on an operating system that the media has in some cases deemed to be hacker software, which is a massive misnomenclature of the term hacker, but I digress. For you PC gamers, what if I told you that you didn't have to play your games on Windows? There's an unbelievable amount of development engineering being done across multiple open source projects and communities to make this happen, except that it's already happening. You're not just limited to a handful of low poly games or anything like that, like pinball or card games or anything very, very basic like that. There's entire operating systems now that are specifically gaming centric. You just have to be willing to step out of your comfort zone and give them a try. To answer the question of whether or not everything works, no, not yet. There is an enormous community working to make this as much of a reality as possible. If not just to drive developers to supporting alternatives to Windows and OS X, but to give you an option that isn't black box closed source software. And that's especially important nowadays, considering how severe the identity theft and privacy issues have become within cyberspace. In the Linux world, there's a significant number of operating systems available to you, and these are just a few of them. And that's one of the greatest advantages of open source. You have options. These are only 4 of them, and for the more advanced user, one of them listed here is Arch Linux. It's a rolling release type operating system, and it's a little bit more on the advanced side. For someone just getting started or wants to test the waters in gaming on Linux, you've got SteamOS and PopOS as great choices. One of the things that a lot of people may or may not know is that SteamOS is what's powering the upcoming Steam Deck from Valve. And Valve is heavily involved in making Windows games run on Linux. And for those 2 operating systems in particular, they're basically turnkey. You install them and install your games, and it basically just works. Then you have Fedora, which is kind of the middle ground. It is easily adoptable. It's fairly bleeding edge, and it also, you can tinker. Well, you can tinker with any version of Linux, but Fedora is a little bit more geared towards the advanced user, or to the middle ground or middle advanced user. And obviously, if you want to get into the nuts and bolts of the operating system, Fedora and Arch are pretty much playgrounds for you. For somebody just starting off, I would recommend PopOS or SteamOS. You have operating systems spun, like I said, specifically for gamers, your SteamOS and PopOS. You have tools like Wine, which lets you run Windows applications in Linux. And you have tools like Vulkan, which are definitely not a Spock reference. Wink, wink, nudge, nudge. It allows you to run the same level of graphics fidelity as anything Direct 3D can do. Now, moving forward, I've got a couple of videos for you to demonstrate. My colleague, Tom Kreider, is going to go into the nuts and bolts of how basically the graphics stack from Vulkan and Wine and Proton and all that good stuff work. And also some demo footage from some games from his machine, all running 4K 60 max settings. I think he's running a 3080 in his machine. And off we go.
Hi, everyone. My name is Tom Kreider. I am an engineer at Red Hat, and one of my hobbies, like many of you, is playing video games. In particular, since I'm an engineer that works regularly on Linux, I play my games on Linux. Most people they play their games on Linux on Windows, and that's perfectly fine. But for me, Linux is my go-to. It's easier for me. I don't have to swap between the two, and a lot of games work on Linux great. Awesome. AAA titles, high-end titles, you name it, they work. There's been a lot of progress in the last 5 years at least, getting gaming on Linux up to speed on the same level as Windows. And people may not be aware of that. So the goal of this video is to kind of go through some of the key components used in what's called Proton, which is it's also known as Steam Play, and it is a set of libraries and applications on Linux that Steam has created, or that Valve has created, to get many of your Windows games running on Linux. Now, at the end of the video here, I'll show you some clips of various games running on Linux, and you can you can judge for yourself what you think about the performance. I think it's pretty awesome, but hopefully it sheds some extra light on, hey, you can actually do this, and it's pretty cool. So yeah, let's go ahead and hop into here and see what we got as far as our components. So first, we'll start with a game. When you have a game, you obviously have your graphics, your audio, and your controls. You want to be able to see the game, you want to be able to hear the game, you want to be able to interact with the game. Obviously, you would also have a section here for networking. That's not added here because it's fairly simple. It's the same thing as the others. It goes from the game through Wine on the Linux side, and then out through the network drivers on the Linux side. There's nothing too complicated about that. But let's talk about some of these more complicated ones. We'll start with the controls and the audio, because those kind of end up at the same location. So we've got our graphics, our audio, and our controls. All of these are normally handled by DirectX on Windows. And DirectX is a set of APIs which consists of Direct3D, X-Audio, and D-Input and X-Input, right? So typically most games on Windows just use DirectX for all three of these. There are a few that don't use Direct3D and instead would use something like your Vulkan or your OpenGL. For example, Doom 2016. That was a big title when it first came out, and it runs like a champion, and it uses Vulkan directly. It doesn't go through Direct3D for its graphics. And the other cool thing about it, it has an OpenGL backend for older hardware. So again, it goes to OpenGL directly. There's no Direct3D involved there. So that's just one example. There are several other games that have Vulkan and OpenGL usage directly. And those also, like I said, those run great in Linux. There's no need for translation there. But let's get into the other two here and continue on. So the audio component for DirectX is X-Audio, and the control input for controllers and devices, USB devices and Bluetooth devices, stuff like that, is their D input is the older one. X input is the one that's more frequently used. But both of these are, again, components of DirectX. For the Linux side, when we run the game, these API calls get sent through Wine, and that starts our next question. What is Wine? Well, I can tell you Wine means Wine is not an emulator. That's been said, so many times on the Linux community that it's basically a meme by now. But the reason that it's specified that it's not an emulator is because we're not creating an entire fake environment. We're not emulating that we're Windows. We're doing direct translation. There's a huge difference here, and the reason that it's a big difference is because translation is not the same as emulating. If you're having a conversation with somebody and that person speaks a different language, and you have a person translating between you, that person is not trying to be you. They're not trying to impersonate you. They're just translating what you're saying. The same thing with Wine. With Wine, when you are running a game, it's translating all those different calls for Direct3D and X-Audio, D-Input, X-Input. It translates them. And the way it does this is using various different libraries to do so. And these libraries are all of these down here that you can see listed. So these are the pretty awesome components of Proton that assist Wine with getting our games running on Linux. It's pretty cool. So on the audio and the D-input side, or the control side, just to get those out of the way because that's a little bit easier to tackle, we've got F-Audio for our audio. F-Audio takes DirectX X-Audio calls, translates them to something that SDL can understand, and then SDL translates the audio. Well, it doesn't translate. It sends the SDL audio calls to our audio backend for Linux. Also, Pulse Audio and Pipewire are all audio backends for Linux, which didn't get sent to the driver. You may notice that SDL is sitting here for both audio and for controls, and that's because SDL is kind of like DirectX, except for it doesn't have the graphics portion. It just has the audio and the D input and X input portions. It only handles those two. So for those two, we direct everything to SDL. Wine is configured to send controller input to SDL directly, while for X Audio, again, it sends it to F Audio, and then F Audio sends it to SDL. So that handles 2 out of our 3 major components here that are needed. The last one is graphics. So let's hop into this now. If you have your game and it has its graphics, it again will either run Direct 3D, or it'll run OpenGL, or it'll run Vulkan directly. Now, I explained that, when it runs those 2 directly, it'll just go through Wine and then come right back out and go to the system. There's no issue there. With DirectX, however, Linux doesn't have Direct 3D. That's a Windows-specific software. So, again, we have to translate that stuff. And to do so, we send the Direct 3D API calls through Wine, and Wine uses a various set of, again, libraries similar to F Audio and SDL for the graphics side. On the graphics side, what we use is DXVK or VKD3D or Wine D3D. And the reason there's so many of these is for a couple of reasons. One, DirectX 9, 10, and 11 came out well before DirectX 12. And when those were being worked on, that's when DXVK came out. And shortly after that, when DirectX 12 came out, we were like, okay, well, we need something else that can handle DirectX 12. And the similarities between DirectX 12 and Vulkan are uncanny. They're pretty dang close. So instead of having just DXVK handle all of it, VKD3D is specifically for DirectX 12. So that's how that works. If it's a 9, 10, 11, a DirectX 9, 10, or 11 game and your GPU supports Vulkan, then you're going to go through DXVK or want to go through DXVK. And that does our translation, goes to Vulkan, goes to our graphics stack, our graphics library, and then it goes to our GPU driver. And for DirectX 12, the same thing goes for VKD3D. Now, let's say you have older hardware and maybe you run, you want to run an old game like one of the older Final Fantasy games. Obviously, you don't need crazy killer hardware to do that, and you may not have crazy killer hardware to do that. But all you're doing is running Final Fantasy, like classic Final Fantasy, right? In that case, you have OpenGL. OpenGL is plenty for that. And obviously, if the game is still meant to run Direct 3D and you don't have a Vulkan backend, Wine will still be able to use the Wine D3D backend for OpenGL. So again, this also handles DirectX or Direct 3D 9, 10, and 11, but it sends the calls to OpenGL instead of Vulkan. So that's the 2 differences. You got your VKD3D and your DXVK, which handle all of Direct 3D going specifically to Vulkan, and then you've got your Wine D3D for DirectX 9, 10, and 11 to OpenGL. And that's it as far as how those work. Let me also talk a little bit about these graphics stacks down here. So you got your Mesa graphics library, and you got your NVIDIA graphics library. And one other one that's missing here is the AMD GPU library, or AMD GPU Pro library. And I didn't add this one because it's not very often used compared to the NVIDIA library. With NVIDIA cards, you have to use their proprietary driver, which unfortunately their drivers are not open source, but they work great. They work really, really well. I mean, each driver has their own quirks. There's always going to be bugs here and there, no matter what. Even on Windows, there's plenty of bugs for that stuff. But the difference here is that the Mesa graphics library and the AMD and Intel GPU drivers are completely open source. In fact, all of this stuff is open source. It's all open. This whole thing, And what that means is that the code is out there for anyone to view, anyone to debug, anyone to troubleshoot. You don't have to rely on some company. You don't have to go and wait for some company and pray that they fix a bug that you found. Now, with NVIDIA, you'll probably have to do that because NVIDIA's drivers are closed source. So you report it and hope for the best. But for AMD's drivers, as long as you're using the open source graphics library and the open source GPU drivers, you can go on their source. You can go to their source code. You can report a bug. You can try to debug it yourself. If you're good at coding, you can try and code the fix yourself. Or who knows, maybe someone else that's from the community may also see it and be like, hey, I know how to fix this. Here's a fix. It's an extra option. It gives you that extra bit of freedom to kind of do what you want, or maybe get things fixed faster than, say, waiting on the company that provided the GPU to fix it. Again, you don't have that with the GPU Pro drivers, but there are advantages to using the GPU Pro drivers as well for AMD. And, you know, for example, if you're running something like DaVinci Resolve, where you need whatever features they have, or you know, transcoding and stuff like that, you can get the open source, or you can get the closed source AMD GPU Pro drivers if you need them. But having this option, the Mesa graphics library and the open source AMD and Intel GPU drivers, is amazing. That is one of the things that has kept me on Linux for the longest time, is the fact that if there's a GPU driver bug or issue, I can go report it and or debug it. Like, I can look at the code and try and figure something out. And, you know, not everyone's a tinkerer. I understand that. But there's nothing wrong with using the NVIDIA driver. There's nothing wrong with using the GPU Pro driver. Whatever tool gets the job done and works well for you, that's perfectly fine. I'm just saying, having open source stuff is really convenient and really freaking cool. Not only that, but AMD also contributes. Not only they work on their GPU Pro driver, but they also contribute code to the Mesa graphics library and the open source drivers. So AMD is kind of like doing double work and giving us a huge favor. So kudos to them for doing that. One of the last topics I want to hop on here is these extra bits here on the side. I'm almost done. I know I've been talking for quite a bit, and I'm trying to keep this as brief as possible. And I know there's a lot of information here, so I hope that people are able to review this, and, you know, if it piques their interest, you know, obviously review it and see if they understand it better. And who knows, maybe somebody in the future will pick up Linux because they saw this and were like, hey, that's really cool. But yeah, anyway, so the last bit here. Yes, all of these work on Linux. AMD FSR, that's a fairly new one that was announced. Now, not only does this work in Linux, but it works on Linux better than it does on Windows. And you want to know why? With Windows, you're restricted to whatever games have implemented FSR directly within the game. With Linux, Proton has what's called a full screen hack. Now, it's not a hack, quote unquote. It's not, you know, some hacker man going in and doing something mischievous. It is what the full screen hack does is it upscales games to your native screen resolution. So let's say you have an older game that runs at like 800 by 600, right? That's a goofy resolution. It's just a big square. Obviously, that's not going to look great if you try to run it on a 4K monitor. And usually when you try to do that, it would try to change your screen resolution to that resolution, and then it would be all goofy and skewed, and it just doesn't look well. So what the full screen hack does is it upscales the game and uses an internal upscaler to make it look presentable and halfway decent on your screen. So, you know, obviously if I run the game, I might have some black bars on the left and right side because it's not the same aspect ratio, but the game is presented and it doesn't change my screen resolution, and I can still view everything and play it perfectly fine. Might be a little blurry because of the upscaling, but it's still perfectly playable, and it's way better than it trying to change my screen resolution, having it skewed and weird. So where does FSR come in? Well, some geniuses that work on Proton have found a way to replace the full screen hack upscaler with FSR. So instead of using the standard upscaling backend, it uses FSR for its upscaling backend, which makes everything look amazing. It's so cool. I've tested this on a couple of games, and it blows things out of the water. Witcher 3 looks phenomenal. Forza Horizon 4 looks awesome. Borderlands 3 works great. Cyberpunk 2077 great. Days Gone looks awesome. Warframe, another really awesome one. I was getting like 250 something FPS at max settings at 4K on that game in Linux. I was like, holy crap. But yes, basically, as long as the game doesn't have its own internal upscaling mechanism and it's able to run on Vulkan through either Vulkan directly or VKD3D or DXVK, it can take advantage of FSR. That's any game. Any freaking game in your Steam library. As long as it uses one of those three and doesn't have an internal upscaler, you get FSR for free. That's pretty awesome. The next few things here, they've got some pros and cons, but we'll go through them because they do work. NVIDIA DLSS. This one works. The current limitation is that it only works for Vulkan games. So games that are Windows games that run Vulkan can use DLSS. However, if they're going through VKD3D or DXVK, it's not implemented yet. It will be. It's a work in progress. Doesn't currently work yet on those two, but direct Vulkan games, like, for example, Doom Eternal, Doom 2016, Wolfenstein 2, Wolfenstein New Blood, or Wolfenstein, the new Wolfenstein 2. It's not New Blood. That was an older one. But regardless, as long as it's a Vulkan game, it works. And it has to have DLSS in the game, but obviously it works. Personally, I prefer FSR, but DLSS works. FreeSync and G-Sync. G-Sync works. You got the NVIDIA drivers. You got an awesome NVIDIA GPU. It runs. You just click a checkbox, and it freaking works. It's on Linux. It's so cool. FreeSync. FreeSync works as well. The only caveat with that is you can't use it on multi-monitor. So if you have, double screens, then you're not going to get FreeSync, unfortunately. But if you have something like an ultra wide, that's your only monitor, hey, you got FreeSync. Yeah, you can crank that baby up. Let's see, what else we got? Resizable bar, that works great. Works across pretty much everything. As long as you've got a CPU and a GPU that support it and you enable it in your BIOS, it works. Ray tracing. Ray tracing also works. In particular, there's some GPU driver limitations. So let me hop into those real quick. It works on the NVIDIA driver, and it works for anything running Vulkan can run the ray tracing if the game has it on the NVIDIA GPU driver. On the AMD open source driver, unfortunately, ray tracing is not currently implemented. It is a work in progress. Don't worry, it's coming. It takes a little bit of time, but it's coming. The AMD GPU Pro driver also has ray tracing working. So if you absolutely have to have ray tracing, you can install it. Or you can install the GPU Pro drivers and have your ray tracing on it on AMD. Excuse me. So yeah, those are some of the major new features or new technologies that have recently come out that work in Linux. And again, some of them work better on Linux than they do on Windows, which is pretty awesome. With that being said, I think I've kind of covered pretty much everything that I have here. Hopefully it piques your interest. Hopefully maybe you decide out of boredom you want to try Linux and jump down this giant rabbit hole of awesomeness. But that's all I got for you. I hope you guys enjoy. Thank you.
What does no lockdown to further nerded? Necessary security measure.
Officer, ma'am. Damn, are we ever lucky we ran into you.
Really? What's it that makes me so special?
Heart of gold? because only somebody with a heart of gold can understand just how much I need to get back to my girl.
Your girl?
Uh-huh. I'm gonna be worried sick if I don't show. I mean, I'm trying to be a stand-up guy. She's giving me a chance. Waiting.
That's a shame.
Look at him. No model citizen, maybe, but he's a good kid.
Let them through. But they're the last. Okay, on your way.
You have a good evening now, officer, ma'am.
So you can be nice when you feel like it.
When am I not nice?
Always?
I'm always never not nice.
Damn it. That's the Sun Smashers camp, but it looks like the COV got there first. Don't let them leave with the map, killer. Smacked down!
There we go.
And thank you for that video, Tom. If you would like to see more footage or go back through the original video, I encourage you to grab, if you're in here, I encourage you to grab your phone and grab a picture of this link so you can watch it in full. The video was shortened for time, but there's examples of Battlefield 5, Rocket League, The Witcher 3, Guilty Gear, Red Dead Redemption 2, and then some. There's a solid 20 minutes of footage there. Or if you want to go through his video, it's available at this link. Or you can check out his YouTube channel at large, where there's tons more content, both in-depth technical, how to get games running in Linux, and plenty more demo footage. For those of you interested in actually putting Linux on your machine or trying it out, well, you kind of need to know how to get it and install it. Full disclosure, the screen grabs that I'm about to show you were done using Windows Hyper-V. And I went this route because most of you are not going to want to just outright nuke your gaming rigs from orbit to give this a try. If you're running Windows 10 Professional or Enterprise, Hyper-V is built in. You can Google how to install it. It's fairly easy. If not, you can use VirtualBox or VMware Player. Both are free for private use. You're not going to be able to run your PC games in a virtual machine. Full disclosure, it's just limitations of VMs and graphical acceleration. It's just not there. The point of this is to give you an opportunity to kind of get a look and feel of how the operating system drives and how to configure it, how to set it up, and so on. All you really have to do is go to one of the websites for the distro, download the ISO. If you're on Windows, you can download a program additionally called Balena Etcher to make your flash drive. Or if you're loading it on a virtual machine, you don't need that at all. You just tell the VM to boot to that ISO file for the installation. Make sure that when you boot your VM, make sure that Secure Boot is either disabled or set to Microsoft UEFI Certificate Authority. When you boot your flash drive, the example I'm showing here is Fedora Linux. This is basically the first thing you're going to see, which is the part of the boot menu. I recommend going with Test This Media, which will run you through a quick test to make sure that the ISO made it to your computer into your flash drive in one piece, because this is about a 4 gigabyte file. Again, for this demo, I'm specifically showing the Fedora game spin. When the OS finally boots up, this is actually where it's going to leave you. You're booted into what's called live media. It is a fully functioning version of the operating system running out of memory and off of the flash drive. The desktop environment that you're looking at is called XFCE. As far as look and feel goes, it's kind of similar to Mac OS. But if you don't like that, it's not a problem. There's about a dozen different graphical interfaces for Linux that you can choose from: install, remove, switch at will on the fly if you want. The first thing you're going to do here for installing on either a bare metal system or into the VM is there's an icon named Install to Hard Drive. You just double click on that. What's going to happen is it's going to bring up this screen, and it's a program called Anaconda. Anaconda is the installer program that is used here and in many other Linux distributions. At this point, the installation is just like Windows. It's kind of a follow the bouncing ball type deal. The first thing you're going to be prompted for is your language and keyboard layout. We're going to go for the default here is US English because we're here in the US. If you're somewhere else, anywhere in the world, select your language and select your keyboard layout. The next thing it's going to give you is a screen with a set of things that need to be done before setup. One thing to note is that the hard drive is not touched until you click Begin Installation. And it's not actually going to let you click that until you've got everything set up that needs to be set up for the installation. We're not going to change the time zone here. Right now, it's just set like default is Los Angeles, West Coast. Here in North Carolina, you change to the East Coast. It's fairly simple. It's a drop-down menu. What you're going to go through next is your installation destination, and it's going to bring you to this screen here. If you don't know what you're doing, just click Done. The defaults are basically suitable for most people, especially for a VM that you're pretty much just going to be playing with. So you don't really need to set too much up. If you got an eye for detail, you notice that I'm only installing to a 25 gigabyte hard drive. It'll install inside of like 10 gigs, but that's bare minimum. I don't recommend going that small on a real installation. You might want to go up to 50 gigs on your demo if you're planning on installing a boatload of stuff, but that's about it. I mean, if you plan on doing some test installations of games, you're going to need to get significantly higher because some of these games are 40, 50, 60 gigabytes. Basically, moving forward, you just click Done, and it's going to return you to the screen that you were just at. What you'll notice is that there's no more little error at the installation destination. Next thing you're going to want to do is configure your user and the root user and set that password. The root user is the equivalent of the administrative user in Windows. You're going to want to make this a very strong password, and I do not recommend allowing root to log in through SSH. And for learning, I would probably recommend unchecking the lock root account box, especially if you're not going to make your user account an administrator. Once you've entered your password, click Done, and it'll send you right back from whence you came. And then you'll see the little warning symbols gone from root, and then you go on to user creation, which now you create your user. You don't have to use your real name. I used mine just for an example here. You do want to set a strong password that is different from the root user. And if you did not unlock the root account, you need to make this user an administrator, especially if you are a beginner, because if you don't know what you're doing, unlocking root or making your user an administrator is not going to be the easiest thing, especially for somebody new. Once that's done, click Done, and you're right back to from which you came again, except you'll notice that the Begin Installation button is now highlighted blue. When you're ready, you just click that, and away it goes. Now let's just hurry up and wait. Go grab a drink, go grab a snack. It won't take too long if you're on solid state media. Once that's done, you'll have finished installation. On the live media, it will return you to the desktop. Under XFCE, you'll just click on the applications menu, log out, and reboot. The next time the machine reboots, you'll pull the flash drive, and it'll boot to the OS. Now, let's say you don't like XFCE, which was what you just saw. That's the default for the Fedora Game Spin. Well, there's other options here too. If you want something more Windows-like, what you're looking at right now is a desktop environment called KDE. It's fairly Windows-like, and for somebody coming from Windows, it's a fairly easy jump. You also have another desktop environment here called Cinnamon. This is the one I personally primarily use. It's also fairly Windows-like, and it's going to be fairly familiar for a Windows user to move from. And then there's the default for Fedora, which is GNOME. And I personally don't use GNOME myself. GNOME has a couple of variants where you can use what you're seeing right now. There's also a GNOME Classic version, which it looks a little bit more like GNOME 2. Right now, that's GNOME. You're looking at GNOME 40. And again, like if you don't like this particular UI, there's nearly a dozen to choose from. You can just go onto Google. You can look at Fedora's website, look at Linux Mint, Pop! OS, any of them. There's a ton to choose from. Now, in the interview, if you watched it, I did promise a bit of a demo. Fortunately, I don't have a lot of time, so we'll get this started. And while you're looking at that, this is the link to the Red Hat Arcade, where these are games that are all open source, many of which have been developed by Red Hatters. And while we're switching over, I will be right back to set you up for the demo machine. No, and y'all are okay. Alrighty, I am good. Hot me. Alrighty, so right now I've got, like I said, stand to deliver. If you'll cut me over to the screen, what you're looking at right now, you probably recognize Final Fantasy 14. It's not like what you're seeing right now is not 4K or anything like that, but what you're seeing, because I mean, we're limited to what we can do for the stream, but what you should see is that for those here and those here can attest, there's not really any stutters, jitters, anything like that. It just works. And this is a full disclosure. This is a Quadro graphics card. It's not really meant for gaming. It's probably the equivalent of a RTX 2070, except that it's got a lot more VRAM. You want to come back to me? So again, this is Final Fantasy 14. It's an older game, so it's not that terribly graphically demanding. If you want to actually cut me back to the, come on. If you want to cut me back to the desktop. Okay. So, and just so y'all can see, this is the Cinnamon desktop. It is very much Linux. Can't type today, but yeah, there's no smoke, no mirrors. This is the real deal. And now what we'll do is I'll turn up the heat a little bit, graphically at least. Now, for this machine, it's not quite as stout as what was shown in the video. This was a Skylake 10-core processor. So really the GPU that's in here is probably bottlenecked by it or close to it. Of course, they're going to make you go through all of this. So, and again, this is not some corporate account. This is my personal Steam account. I do own this game. So loading time, again, loading time is kind of restricted by your hardware. And of course, as big as Horizon Zero Dawn is, it takes a little while to load. I've got the other machine I have at home is a i9-9900KS, and it takes just as long to load on it. And what you're looking at right now, I did bring the computer down to 1080, but it is running max settings otherwise, which I will show. So display graphics. So everything pegged to ultra. So no screwing around here, no smoke, no mirrors. This is the game. We'll exit out of this. And if you want to cut back over to me. So you would think that, come on. Screw this. This is an Xbox controller. It's not a knockoff, it's the real deal. And the game I'm about to fire up now is Dirt 5. And sorry for the kind of clunky thing. We've hit Murphy's Law for every AV issue possible today. Of course, loading screens, more loading screens. Okay. And again, game I own. Close all this stuff. Let's just go to career. And I'll skip this because time. And I've owned this game for a grand total of a day, so this isn't something that I've smoke tested in advance. I'm not joking. I installed this last night. So I know that for those in here, the audio is kind of, and obviously I can't drive because I'm not half paying attention. But the audio is going through the live stream because AV issues galore. Of course, I can't drive because I can't drive. And somebody's trying to spin me. But yeah, it's really just pushing this thing to it as far as it would go. And for those here, if we've got a little bit of time, when we unhook all the AV stuff, I will fire this thing up at 1440 if y'all want to see that. And one last demo for you guys as soon as I get out of this. Go to, well, we were just going to do those three because of the time constraints. Are there any kids watching this?
I can't tell. I can just see what the streams are.
If you are under the age of 16, avert your eyes. Oh no, it's doing this again. I set all this up yesterday. I might have messed it up when I did the software update. Well, really, as far as streaming goes, I don't, since we're not limiting this to 18 plus, probably shouldn't play Doom, but if y'all want to see Doom demoed 4K, I'll do it for the folks here in the room since I know everyone here is of age. But yeah, so I'd really appreciate y'all's time today. If you want to know more, again, check out Eggy's page. What we call him Eggy at work. Tom Kreider, also known as the Glorious Egg Roll, which is what we call him Eggy. And then myself, Joe Too Cold Wright, signing off, and y'all have a good one.